Hey everyone, good evening. I'm Dana Gordon. I work with Dr. Tom Stableline. He runs the Masters of Science in AI and Business Analytics at USF Muma. I'm sure most of you know the university well. The program is really proud to sponsor these events. It's a pleasure to be able to connect all the local tech leaders and tech community by offering these meetups. So we've been doing this, I think, going on 3 years now. It's been amazing turnout. You know, we obviously sell out our tickets every single month. So thank you so much for coming out tonight, even though I've been told a million times traffic was awful tonight. So thank you so much for showing up. Tom is traveling with his family at the moment. He always takes a few weeks in July to go see his family because, you know, he's keeping very busy running the program. So I'm happy to fill in for him this evening. But he did ask me to mention that he is working on some really interesting Gen AI stuff. So if that's your jam and you want to talk to him about it, feel free to reach out at any time. He loves to meet new people and talk with people who have interest in that. So feel free to reach out, or he's on LinkedIn, but if you want to reach out to me and have me do the intro, totally fine. Reach out to me as well. Past few months, they have been incredibly busy with our program. There's been a lot of interest because obviously we have all the new AI focused coursework. So we're completely rewriting everything essentially from scratch. So if you or your teammates really want to scale up your competencies, it's a really excellent program. It could be completed in less than 2 years, which is pretty fast comparatively for a Masters of Science program. So we're excited to offer that. So if you have any questions, reach out to me. And at the moment, I would like to introduce today's speaker. So Tony is a seasoned technologist with over 2 decades of experience in the industry. And Tony's expertise spans various domains, from software development to data engineering and machine learning. And currently he holds a pivotal role as leader of data engineering and machine learning at Juvae. Did I say that right?
Yeah.
A cutting edge travel focused company that's dedicated to making the travel experience seamless and simple for both partners and guests. Before that, he worked with Autonomy, leading the implementation for several initiatives, namely telematics implementation, which ingested over 10 million data points daily. And with a unique blend of technical prowess, leadership, and a background in the automotive, maritime, and aviation industries, Tony brings a wealth of knowledge that is uniquely difficult to find in a single package. His presentation today will focus on assisting neural networks with real-time data. Please help me welcome Tony.
That was a lot, Dana. All right. It's gonna be a little rough, but my aim today is to walk through like my career as it applies to what we're doing now with data, and then talk about how we're applying that and how we're trying to get to this point of true seamlessness. So I have a little presentation here. All right. So yeah, so like I was saying, our objective is to come up with these curations for each individual person that uses our platform. Typical use case is this. Someone reaches out to us, they say they have, for instance, an anniversary that they want to plan. This anniversary entails obviously their partner, kids, family, friends that they are going to join that trip. Sometimes they need to share payments, they need to do split payments. Other things that they may need actually get into the location. So taxi, they need, and we primarily focus in the Caribbean. I should have led with that. So there's a lot of transport between different islands as these guests come in. So we need to then coordinate those things with different partners that we work with. Now, it's a lot to do all of that. A lot of calling, a lot of emailing, a lot of texting, a lot of trying to figure out. You're trying to make sure if something is available, the partner you're working with, they may not be in the office because they're off site, they're on a boat somewhere, dealing with other guests. So in trying to streamline the whole process, we need to involve people and get people on the same system. Now, there's a lot of systems out there that people use. There's some companies like Fair Harbor, Bookeasy, Airbnb is a very popular one, Expedia, and it's the industry is very segmented in that, right? So how do we now get everyone on the same page and then be able to take simple human interpretation, human requests and turn them into these curations that they could just complete, confirm, and then enjoy the experience. So walking through, these are the areas that I want to cover in this presentation. So attention, neuroscience, orchestration. I'm gonna touch on each one real quick. So there's some things that happened 2017, if any one of us are remember or are familiar with what Google did with the transformer architecture when it comes to large language models. And that was all about attention is all you need. And basically what Google figured out was having this transformer architecture and being able to have attention, right? Backwards and forward of what you're feeding into a program, you're able to then have better predictions and do it more efficiently, right? So a lot of this is based on neuroscience, right? As we go through, we talk about how we're thinking about architecting a machine learning system and not just using one particular model, as our brain doesn't work that way. We're using different models to communicate with each other and then inference across those models to come up with plans and orchestrate those plans so that we can come up with that curation, like I mentioned, right? Infrastructure, agents, models, like I already mentioned models already, but infrastructure specifically, we're talking about how we actually run these systems. How do we run them in the cloud? There's things you need to think about scalability, you need to think about the cost, right? These things can be very expensive if you don't take into consideration, the size of your model and what it takes to actually make inferences against it, basically asking that model questions and getting a response back. Agents is something that's fairly new in the machine learning world. You have multiple individual models that may specialize in a particular area, and then you're able to have those agents communicate with each other or collaborate in some type of way. What we do, we have a planner that works with different agents to then come up with to do different things to kind of figure out what's available, when it's available, the cost of it, and then we do some recommendations. We're not fully there with the recommendations yet, but that is something that we do have. I can't comment on that yet, but we do have some implementation where agents are able to use a recommendation implementation to figure out, okay, what would this person like in this particular context based on who they are, based on what type of collaboration filters that we have around them and whatnot. That's not me, right? But that's my name. I'm gonna skip this slide because obviously. So this is like my beginning, right? I got a gateway computer a long time ago, and the only thing I cared about doing at the time was downloading music with Napster. If anybody remember that thing with the little alien head, right? That was the first and last time I committed a federal crime. So this is it. And one of the cool things that to be honest, I pulled this off of ChatGPT because I have no idea what I wrote back then. But what I did do is I did figure out a way to rename all the music files that I had based on an album. So I could then organize it and I could play, okay, this is album, that album, that album, that album. So things that I could do with writing code, writing instructions to the computer seemed very interesting to me. And I just kept on going with that. And then I started working at this resort, Canil Bay. This is in the Virgin Islands. This is where I work in the reservation department. I did a lot of work with just, as it says, right? Reservations, making sure guests had payments. We did things with marine operations because the hotel itself has a boat, and that's the boat right there. What we would do is the guests would arrive, we would then schedule the boat to pick the guests up from the airport, bring them to St. John. They get to the hotel, like that boat is, and then we'll check them in, get their bags, their luggage to the rooms, regular hotel, hotel check-in procedure. But I learned a lot from Canil Bay, right? Where we had this one system, and the name of that system was Fidelio, and we was able to coordinate across all these different departments, right? We had housekeeping, we had central storage that dealt with food or bed sheets and whatnot. We had housekeeping that did something similar as far as cleaning the rooms, reservations, guest activities and whatnot. All that stuff was in one particular system. And that was a while ago. So this isn't like this is some new thing today. But the industry grew and grew and grew, and things just become more and more segmented because there's more and more companies doing different offerings, different specialties or whatnot. So you have that. So then you end up with these data silos, right? And that's the biggest headache. Now, I got tricked to join these guys, right? If anybody been in the military, you know, there's a point where you get in boot camp and you're talking to your fellow recruits and they're like, well, my recruiter said this. Well, my recruiter said this. And it was all lies. But it was one of the best decisions I've ever made. I have this here because my position in the Navy was an avionics technician. And when I did that, not knowing what it was about, it fit right into what I was doing, right? Well, what I enjoyed, I should say. So dealing with computers, dealing with GPS systems, radar, weapon systems and whatnot. And we would have to test these systems, you know, when they go down, running hexadecimal codes against them to figure out, you know, where different faults are within the system. So, you know, tinkering and stuff, that was always my thing. I got deployed overseas. My chief, you know, he thought it was funny that, you know, thought it was giving me a vacation. That's what he called it. And it was a vacation to Anaconda Balad. And in Anaconda, what we did was we focused on specialized ops that were targeting specialized individuals. And there was a big command center in Balad. It was a central hub of Operation Iraqi Freedom. And in that centralized hub, we work with something called a Blue Force tracker. And what we would do every day, we'll get these codes, cryptographic codes that we'll use to load the radios up so we could communicate securely across different units. Once you would do that, then like you see here in this helicopter shot, we would then upload that information to the central location at the base in Anaconda. And then the generals, and the admirals, they'll do their battle planning. And again, you're seeing this pattern, you're seeing data being lifted from the battlefield or lifted from the hotel field into a central system. And then that data is being analyzed on. But the commonality between, you know, the hotel example and this example now is that you had humans having to go through all this data and figure out what to do. What's the next thing? You know, what's the situation with this guest or this soldier or this aircraft or this vessel? And how do we now act on that? What do we do? So I left the military, and then this is all I said I would do. I would code for food. You guys not laughing? I thought I was funny, but no, once I left the Navy, I got back into that mode of trying to figure out, okay, I want to create something that makes people have fun, right? I want to be a part of that. So how do I do that? And I had no idea how I was going to do that. So I would just do like web projects for different companies that was locally. I moved back to the Virgin Islands and I would do it for different companies that was there. So that was cool. And then I said, you know what? I'm a pilot, so let me buy a plane. And I'll start an air charter company. So that was the idea. Granted, perfect thing, right? But then I didn't have any money. So it cost $8 million for a plane like this. And I didn't have access to $8 million, unfortunately. I didn't have a rich uncle, really unfortunately. So I had to figure out something else to do. And then, but let me stay here for a second. You know, knowing how aviation works, that's another segment of, again, the same pattern again. You have all this data, you have passengers, you have pricing, you have fuel consumption, you have location, you have airport location, you have routing, you have a number of different factors and vectors that come together that also you could provide people with a particular service or a particular experience, right? So moving on from this, I then got into this company, Island Life. And it was all about just taking people from different islands, showing them a great time. But what I saw was an opportunity to have this intimate relationship with a lot of people and start to get to know them and understand what were their true wants and needs, right? In the sense of having a great time. So this is a snippet of what we did. Over the course of 5 years, we did probably I don't know, probably about 1,500, 2,000 trips like this. And it was a blessing because we met so many people, older, younger, just from different backgrounds, and for them to give us all this information about what they were doing. This is at the time where Airbnb probably was 3 years old, you know? So of course, we want to be like Airbnb, you want to be the next, $100 billion company, but have no idea how to do that. So moving on, we had some pretty devastating hurricanes in 2017, and that shut everything down. And had to kind of go back to my grassroots, which is coding, engineer. And I did that for the last 7 years. And in that time, I worked with a company, I worked with Autonomy. And what we did at Autonomy really opened my eyes to see a lot of how we could harness this data and use it in different ways, right? To provide these different experiences. And the main thing about doing that was having the data in a central location. So breaking down these data silos and then figuring out, okay, how do we ask the data questions? How do we do inferences on the data, right? We did a lot of data science at Autonomy. What we didn't do was machine learning, and we started getting into machine learning towards the end of my tenure. And what was really interesting was what we were able to do with telematics. I have to be careful what I talk about. Autonomy might go public. But the main thing that we did was we were able to see when we did all Teslas, we were able to see what vehicles what they were doing, how fast they were going, what the battery charge was. We understood the financial metrics behind the vehicles. And then we were able to take that information and then ask questions like, well, how much revenue are we making per mile or per customer? Some customers were paying more revenue per mile than other customers because, one customer will be able to use the vehicle, maybe once a week because they're always traveling. Another customer is using the vehicle all the time. We have some customers that were using the vehicle to do Uber, for instance, right? So they're going to have we're going to make a lower revenue per mile because they're using a lot of miles. And then those mileage, the more mileage, right? That's decreasing the value or at least the stability of the vehicle itself. So, like I said, that was just really insightful. And then getting into machine learning, the first thing was, what is machine learning, right? What is AI? And for me, the hardest thing to get over was the fact that machine learning is non-deterministic. And we humans are non-deterministic, meaning that we're very variable in the way that we think and what we want and what we do, right? But then when you program in a computer, like that script I showed you guys earlier, you're giving it specific deterministic instructions and saying, do this, if this, then do that. And if that doesn't happen, do this, right? So how do we get this computer to be non-deterministic? And it's not the computer, right? It's a program, and really comes down to math. And that was the breakthrough that we had when thinking about how to build this experience, this seamless experience. And the breakthrough was simply this, right? Taking a person's query, a person's prompt, and then converting that into something that a computer can understand, which is just a list of numbers, a vector. And then taking that vector and running mathematical calculations on it, a lot of times, like billions and trillions of times in some instances, and then coming back with something that matches, okay, this is the question that was asked. This is more than likely what's going to be the response that this person is going to want. So next, what I'm gonna dive in here to now is just an architectural overview of what we're doing at Juvae. All right. So here what we have is a prompt. what we're working on right now is just like everybody's familiar with ChatGPT, right? Okay, so what we're doing is just like you would prompt ChatGPT, we're taking that prompt and then we're passing it into a particular converter, right? Whether it's audio, if it's text, if it's image or whatnot. So let's just focus on text, right? That's simple. That text is then converted into an embedding. That's exactly what ChatGPT would do whenever you type a prompt. And again, an embedding is nothing more than just imagine that you were able to just convert this sentence, so these words, this question into a list of numbers. All right. That list of numbers is going to end up going into the model. Now, for us, before we send that into the model, we have a guard. Right, we're using a source from NVIDIA that provides basically a safety guard, because you want to make sure that people are not asking nefarious questions to the model, like how to make a bomb, right? You want, safety is a big concern for us. So it goes to this and it filters and makes sure that this is not something that the model that should not be fed into the model. And also this is a two-way street. So it's make sure, like, even if for some reason you jailbreak the model and you're able to pass questions in, we're also trying to make sure the model doesn't return a response that is nefarious, right? Based on that prompt. All right. The next step now, we have this agent core, and this agent core is not specialized in the area. Its job is to figure out how to route this query, route this response, this prompt or this request is that we like to call it. Based on the request is going to route. So let's say you're trying to plan a wedding. Okay. Well, there's a model that's specifically for that understands, okay, the dynamics of planning an event, not specifically a wedding, but an event. If you're just trying to see if something is available, well, now we're going to route you to a tool, because you just want to make a call to an API to see if this particular thing is available or not. So there's no need to call a large language model for that, right? And that's an important key, and I'll get to it in a second. So depend on whatever it is that you want to do, we're gonna route it. And here you see that routing happening, the semantic router. So that's another step based on the semantics of the query itself. So semantics, we think of it as, like, I don't want to say context, but the vibe of the query, normally you will hear semantics like if this comment was positive, if it was neutral, if it was negative. So we use semantic router to go through that. There's one that recently came out. I forgot the name of it. We're looking at it, but I forgot the name of it. It came out on Chatbot Arena. These guys came up with it, and it seems to do a really good job in handling a number of different models. So ChatGPT 4o, Llama 70B, Llama 8B, Pi, and what it's doing is saying, okay, which model is best for this particular question? You don't want to have to call ChatGPT 4o every single time. You need for a simple question that could be answered by a smaller model, right? There's opportunities to run these models on device. You don't want to run these models on device. You're not going to run a ChatGPT 4o on device, right? Or a model or Llama 70B on device, right? I'm talking about like a mobile phone. So there's things that we want to do to make sure we go to the right model based on the actual query itself. Next thing, again, these are individual agents. These agents, what they do is, again, based on which agent it goes to, the agent is going to do a specific thing. An agent could do something as simple as a calculator, but that's a little bit for an agent. Mostly you'll have a tool, which will be a calculator that the agent would have access to. But you could do it like that. We have another agent down here for search. So if you're searching the web, for instance, or searching, what we do is we use OpenSearch, which is a service by anybody familiar with Elasticsearch? Yeah. So AWS did their thing, they had some beef, and then now AWS is still doing their thing. So we use the AWS version right now. And we're doing that to search against data that we have about what's available, not what's available, sorry, just about the different items that we have. An item is anything that you can experience. So if it's a boat trip, if it's a vacation home, if it's a taxi, if it's a restaurant, a massaging service, these are different items that we have, and that's one of the one of the agents we have that's able to search those things. Now, at the top, you see we have this agent, and I have this tag on it called RAG. Anyone familiar with RAG is?
Yeah.
Okay, good, perfect. So that one is pretty simple. I mean, we're literally just going to a vector database. So the agent is able to have access to his own database, right? And that vector database, again, is not a database of records of rows of text. I mean, it does have text in there, but what it's indexed against is the vectors themselves, right? And is able to do math on those vectors and get the similarity score between them. So one of the things we look at is cosine similarity, which is just, for the lack of for not going into too deep into that part, you're just trying to see how close are these two things are together, right? And get the top ranking ones to get that back. So in the and the beautiful thing about that is, so with our partners, especially the vacation home partners, every vacation home owner almost has their own policy, right? No kids, no smoking, no pets, only small pets. We had an issue last year where someone fell over a balcony because they were drunk, and then there was a lawsuit that ensued. So there's different policies in place for these different things, and each of these homes are owned by an individual person for the most part. So then we need now to have them give them the ability to have their own individual policies. And then when someone is trying to book something and they're saying, hey, I have, 4 kids and a dog, but I want to book this particular unit. Well, okay, cool. We're going to see if you can do that. And that's able to look at the policy and make sure and say, okay, this can happen based on the rules of this particular unit. If it is, it comes back, and then it goes right, it basically goes right back out to the guest as a response. And in these agents, they're just making an API call. The example I gave earlier is where you're trying to see if something is available. Then this agent doesn't need to be ChatGPT 4.0, which is 4.0 right here, right? This is just making an API call availability service, and see if this particular thing is available, right? And then return that back to the user if that was the question, or determine and say, okay, I need to pass this back to the planner, because now they're trying to plan something. They're trying to plan something with this whole thing. So we're not checking to see if it's available for the purpose of just telling the guest. We're trying to see if it's available so that the guest can actually book it. One interesting issue we had with that was you would make, in load testing this, you would have a request that comes in that says, okay, I want to see if this is available. I want to book it. And then another request would come in with the same thing. And then booking is a two-step process, right? We have to see if it's available. And then we also have to check the payment, right? That we can actually charge for this thing. So if those two things actually happen, then we confirm the booking. But what was happening is that when we make that request, the first instant is going to say, okay, I'm going to go ahead and book this. Second request comes in. It's available because it wasn't confirmed yet. And now you have these two requests trying to book something at the same time, right? So we had to essentially lock that down, implement some idempotency to make it so that whenever that request comes in, it's like, hey, I'm trying to book this, it can lock it for a few milliseconds, try and do its thing. And then after that, it can come back and say, okay, I still have the lock. I'm going to go ahead and confirm the actual booking. And yes, the planner does that, but it does it through going back to one of these agents. And the agent is who's acquiring that lock and making sure that it can actually do that. So So yeah, so once and in the beginning, you saw that word curations, right? This is all about getting all the things you want to book into one package, right? And that's our goal. Our goal is to where you don't have to go everywhere to try and figure out how you can plan this vacation. You can go to one location and you can plan and book everything that you need to do, right? So that agent core, what it's going to do is it's going to, just like a travel agent, it's going to go and it's going to try and collect all these different locks and try and book everything that you want in that particular instance when you're requesting, hey, I want to book this particular thing. Now, one of the things that Dana mentioned is one of my specialties was taking real-time data and updating a system. And the tricky thing, one of the things is, especially with machine learning systems now, right? And also just one of the tricky things with doing this presentation is we were building out this thing and doing testing on it, and so much was changing at the same time, right? So much new open source projects coming. We're like, oh my gosh, we gotta use that one. Oh, we need to use that. Oh my God, I don't know what to do. So what we had to realize is we got to stick to what's true, which is the data, right? At the end of the day, that's what matters, right? You could have the best model in the world, garbage in, garbage out. So how do we get the best data and how do we feed it to the model in a way, or the models in a way that makes sense? Just assuming that we have Llama 70B. We do not want to, every time data comes in, train that model, right? That doesn't make much sense. So we have things like RAG, right? So how do we get that data in a pipeline into our vector store? So what we're working on now is we have an instance of Kafka spun up, and everything that the click stream that comes in from the guests, we're then taking that data on a Kafka topic and then piping that into what we call a reservoir. We're using Snowflake for that, right? And then we have jobs that, based on the data that's coming in, if it's data that's about something that's not immediate, meaning it was like someone they left a comment on a particular service, right? If it was a positive comment or a neutral comment, we might give that a low ranking because it's like, okay, we don't need to update the entire system right now for that. But if it's a negative comment, like this person didn't provide the service, we need to update the system immediately so that you don't try and book that thing and then you end up with the same situation too. So we have different ranking for the type of data that are coming in, and we're able to use a pipe on Kafka to be able to rank that data as it's coming in. And this is not machine learning. This is just regular looking at semantics and saying, okay, this is good, rank this that way or whatnot. Now, that data now is coming in from what we call our experience graph. And this is a snippet of our graph database of what how our data looks like and how it's connected. So we all familiar with what a graph database is? All right. So we have these nodes. Each individual dot here is a node. Where you go. Yeah, each of these dots is a node and it represents something in the system. So this one represents a partner. And a partner is a company that provides experiences, right? So they provide taxi service, they provide a boating service, it could be an airline. We don't do airlines at this point, but it could be anything, any type of company that provides a service is a partner. And that partner may have one or more different experiences that they provide. So right here, you see that you have this experience node, and then this experience node now is connected to other nodes and has different type of relationships. So if you look at this one, I think that's a rate. Yeah. So now between these nodes, we have relationships that we're able to see like, okay, this is how this is how this particular boat charter experience relates to this other experience. One of the tricky things that we had to figure out from a data model perspective was how do we had to separate the experience from the actual resource that you are going to use for that experience. So we have situations, for instance, like you have a boat. That boat may do water taxi, so it takes you from point A to point B. And then you also have, and it also does day charters, and it also does fishing charters. So that's 3 different experiences that one resource does. So we needed to have this orange node in the center. That's the resource itself. That's the physical asset. And then that physical asset is able to provide this experience at that particular rate. All right. And these are the blue dots around here. These are the images that are connected to that particular resource. And there's some magic behind that, because now when people, and we don't have this feature implemented yet, but eventually people will be able to share their own images of things that they have done and be rewarded for that. And what we hope to do is be able to see, okay, well, your images are close to these images for this particular resource and it's tied to this particular experience, and you are friends with this particular person. I should probably recommend these experiences to that particular person, right? So that's the direction we're going with that. But to bring everything full circle now, this is our experience graph. The beautiful thing about this graph is that it's not just giving us data about a specific one thing. The data in a graph is really the relationships, right? That's the data, not just the nodes, but the actual relationships. And every time something happens in the system, this is event driven. So this this graph is updated every time, and this is running locally, so this is not live, but this is updating every time someone does something in the system. So if a partner signs up, if they add an experience, if they update a rate or whatnot, everything is happening in the graph, and that stuff is piped to Kafka, and then that happens, and then that's graded, and then we re-rank that, deciding what model to train that or just to add it to the vector store. And then back to the architecture, like I just showed you guys, which is showing you how this all ties in together when now a guest is actually making a request, making a query. So in all, that's how we're taking these natural language requests, and we're getting to the point where we're able to provide an experience, right? That the best that we can matches what each individual person wants to do. And also, if it's a group, what the people in the group wants to do. And that is my presentation.
Good job, Tony. Thank you so much.
I also damn nervous. Y'all gonna know.
No, it's all good.
Any questions?
Yes, we do want to open this up. We'll do a good 10 minutes of Q&A. So any questions, feel free.
Can you talk a little bit about your organization, how many people are in it, and how many people in the IT department, what your role is in the IT department?
So I run the IT department, or the engineering department. It's seven of us total. We do contract out from time to time. Oh, we have contracted out from time to time. Company from Latin America we use for engineers. But full time it's 7 of us. Yes.
Anything you guys showing any of them
Honestly, I think it's just comfort. Me personally, when I first got into cloud computing, I got certified with AWS. And then the companies I work for, I've never worked for a company that wasn't on AWS. But what I would say, I have broken out of that shell kind of recently, because I have seen areas where GCP, for instance, is seen to be more cost effective on when it comes to inference. But we're also playing with this company called Grok, and they're like way better, but I'm not there yet to feel like they're ready for the long haul in production. But you know, I think with cloud providers, I think all of them do a really good job. They have really good products. It just comes down to, you know, what your comfort level is, what your team experience is, and then what your budget is, you know, and what they provide. So yes.
What is the oncology meeting was doing with graph?
Say that again.
Do you have an oncology again, graph?
Yes. So it is, what we try to do is map the graph to the real world. So you say I talked about we have partners, right? And a partner is not a person. A partner is a business entity. And that business entity is owned by a person. That person may have access to the partnership, right? So they're admin, they're the owner, they're an employee or whatnot. Every person that touches the platform is considered a guest, right? A really good scenario to explain why we did that is one of our partners, he's a traveler, he owns a property, and he's an investor. So that one person doesn't need to have 3 different logins to the system. And then his property, different people have access to actually book the property. So now we need to just focus on permissions and not say, okay, you're a manager now, so you need to have a manager account, and it just didn't really make that much sense. And it was, in my opinion, I made a call for this. It was data redundancy. I mean, it was just extra data duplication for no real benefit. So guest partners, experiences, those are anything that you are going to experience. So a boat ride, a plane ride, staying at a vacation home, a taxi, those are experiences. And then we have the assets, which we call resources. Those resources are the physical things, so the vehicle, the boat. A guest can be considered a resource if that guest has a qualification. Like for instance, if you're a captain, right? You have that captain qualification. In order to book a boat trip, you need to have a boat and a captain. So those 2 things have to be available. So this captain needs to be available on that day, the boat available on that day, and then you can have that experience. That experience can happen. Answer your question?
So you started out with a blank graph and you added basically the entities, you built the graph from scratch.
Yeah, yes.
I have a question.
Yes.
Can you speak a little bit more about your embedding model, which basically takes the user query and converts into vectors? Do you use the LLMs to get the embeddings, or do you train your own custom embedding model?
No, we don't do that. So we went down that route of trying to customize things. These models are becoming they already are commoditized. I mean, you could walk down the street, there's a model on the corner of the street at this point in time, right? I think for the initial one, we use the GPT-4 embedding model to convert that into the vectors to go into that first. No. We use the tokenizer. We use a tokenizer from a company called Unsplash. So we use a tokenizer in the model. So we give them the models to the Llama 70B. We choose a model, and then it gives you back a tokenizer and the model. And then we train the model. We do the weighting. There's some adaptation in there, some low ranking adaptation in there that we do. And then, so we have that tokenizer, we have the model, query comes in, pass it to tokenizer, pass it to the model, then it does its thing, and then we get it back.
So do you actively collect feedback based on like once the user inputs a query and based on what result it gets? Because your embedding model, as good as it gets, the results are going to be likely better.
Yeah.
So
we don't have that loop in place yet, but we are monitoring it. So every query that comes in, and we're still testing this, but every query that comes in, we're looking at the query, looking at the quality of the response from the model. And then we're also looking at the query, the response from the model, and we're looking at the user actually like it felt that the response was good, right? Like for instance, if you ask you want a taxi to pick you up from this location, that location on St. Thomas, for instance, one of the islands, right? And it gives you back the availability for a taxi in St. Croix, that's bad. So we mark that, and then we look back and say, okay, why did it pick St. Croix? Like, why did it diverge to a different location and what the person didn't ask?
Okay.
Mhm.
Good,
Often are you writing things on device versus sending them to ChatGPT or other sort of like kind of models?
So we're not running anything on device right now. I think that's fairly new. We're really excited about Apple's new updates with
With Apple Intelligence or something else?
yeah, with Apple Intelligence. More so, I personally feel that Apple, the setup right now is you're able to choose right now with ChatGPT 4.0, you're gonna be able to choose, they left that open to choose different models, right? And more than likely Apple's gonna come out, they already came out with their own models that was open source. And they have App Intelligence. So the hope is that we want to get on device, meaning that those frivolous queries that a guest may ask, like, is it gonna rain today? Things that we can run on device, or not even run on device, but whatever API is available that we can make direct calls and then get that. Well, no, we would have to run that through a model on device, being that it's a human question, right? Like, is it gonna rain today? But those are small models, but Apple would have to provide that. Google would have to provide that and give us access to the APIs to do that. But right now, we're just like paying close attention to it, and it's not something that's fully that's available as far as I know.
You feel like the frequent questions, it's possible that you would have your own sort of model that would save the questions that are asked daily that maybe you wouldn't need to send the GPT for, or maybe you wouldn't necessarily.
That's a good point.
Because I imagine that I don't know how you're using stuff like with your integration per se, but I imagine it'd be the same question over and over again, traveling to like, is this a 321 Max or 321 Neo, or is it a regular 321? Is it 737 Max? Is it
Right.
what is the planes? I mean, you're not really working with airlines, but let's say a route is always serviced by a certain boat, and it's never going to be serviced by a different boat because of size, weights, whatever.
Mhm.
That would be something that you can kind of save locally to your database, and maybe you wouldn't need to necessarily run that on device or the GPT-4 because you already know the answer, because it will never change.
Yeah, I mean, I agree with you 100%. I think, in my method has always been like, get it working as fast as possible, then go back and figure out how to make it more efficient. And right now we're in the get it working as fast as possible stage. But I think you're totally right. Like when large language models came out, like the best of us are still trying to figure out, like, there's always something new and trying to figure out like what's the best way to to do this thing. I think like what's that thing called? Low ranking adaptation. When you're taking the model, this big model, and then you're saying, okay, well, I just want to fine tune these weights a little bit, right? Because I don't want to mess up the whole entire model of how it has been trained. And that takes a lot less memory, a lot less compute to do that particular thing. Like those little techniques, you're not even changing like the infrastructure, the architecture of the chip or of the model itself. You're just making like small adjustments to it. Even the transformer paper, right? That was a technique, that was a change in technique and how we do these things. So I think that from speaking for myself, there's so much opportunity and so much unknown that is trying to, the name of the game for us is trying to stay close enough to the edge as far as, what's happening and be ready to implement what's needed to be implemented. So something like what you just described, okay, we're running, inferences and we're seeing that, okay, we're paying, $30,000 a month in server costs just for these inferences. And it's like, you know what? I've seen this question like 50 times, let's save this and then have a small model. If you see this question, just get the hard answer, right? And bring the hard answer back, or like RAG is able to go and get the actual thing and bring it back to you and say, this is exactly what the policy says. So that's going to take a lot less than querying ChatGPT-4, for instance, and saying, hey, get this thing. And just one quick note on that. One thing I did realize recently, every time that you, like, even with RAG, what we were doing that was very inefficient was pulling the whole entire document every single time to answer the question. And the model will then have to read that whole entire document every single time to answer that question. So then I was like, okay, we need to chunk this thing up in pieces and figure out, okay, what part of the document to get so that we can answer that specific question that person is asking. And then in addition to that, figure out, okay, we have this chunk, but the question is a two-part question and the answer is down here in the document. So we need to get this chunk and then also get that chunk and not get the whole document, put those two chunks into context and then answer the question based on just those two chunks and not the whole entire document. So like I say, there's a lot of optimization playing around. The biggest thing is monitoring, just keeping an eye on the key metrics, you know, cost, efficiency, safety, and just go at it.
Thank you.
Yeah, no problem.
Can you show us?
Huh?
Can you show us?
That I can't show you. That is still, we have a private beta right now that we have up, where's my thing? Yeah, we have a private beta we have out right now, but I tried to have a demo up today, but I'm just not at liberty to demonstrate that to the public as yet. And I'm upset about that, so what am I doing? Yeah. So this is where it's at today. It's very simple as far as what we have in the beta. What we're doing right now is we're testing that click stream. So people that are logged in, we have certain people that are using it right now, and they're clicking on things that they like, and then just going through the different sections of different experiences and types that we have listed right now. A lot of stuff that we still do is manual. So we're still, when you click on that, you go through the process, you still would have to, we literally get an email and automatically send that email to the partner, and then they respond, and then we're using Twilio and we're using a llama model just to do that communication back and forth. Very simple. But the main thing that we're getting right now from the front end is that clickstream data, and we're testing to see how well that data is performing against the actual thing. But I just can't show it right now.
Yeah, just two quick questions. So you mentioned you were using Llama 70B a lot. Have you seen it have a lot of hallucinations? Because you played with it.
Yes.
A lot of hallucinations.
Yes.
And the second part is, so with that, you mentioned you're doing some monitoring. Are you using a third party, or are you guys just manually trying to eyeball stuff right now?
So no, we was using Langsmith. We was using Langsmith. Moving away from LangChain altogether, I feel like it's a lot of abstractions.
Llama Index is better.
Yeah, I haven't played with Llama Index. I haven't touched it, to be honest with you. But a lot of stuff that we see in LangChain is like, you could do it just raw Python, you could do it, right? And then the other, you know, they do have some convenient things that is able to spin up real quick and prototype. But then now you're LangChain, then Langsmith, Langserve, and you're getting caught up in the ecosystem, and then we just don't need all of that. So what was beautiful, forgot the name of the project, but there's an open source project, and they're basically implementing open telemetry into monitoring, machine learning monitoring, right? And we already have open telemetry throughout Kubernetes, and you have tracing, all stuff through that. And the fact that it's an open standard is widely acceptable, I'm pretty excited about that. So, and that's being viewed in Grafana. So that's where we are right now with the monitoring. And we're basically looking at the cost and the cost and efficiency is the two parameters we're looking at majority right now.
When you're trying to implement something like that, like just AI in general, what is your strategy to, I guess, decide how you break it out into like when you're going to hit a certain model or a fine-tuned model against your routing? Like, do you just start out with one big thing and then you kind of add as needed, or do you have a plan kind of to begin with?
Start with a big thing, take away as needed, right? I want to get as close to zero as possible, which is not possible. But that's like the goal, right? That's the direction we want to go. Zero in the cost of latency, zero in the in the sense of in cost. So start off with Llama 70B, for instance, well, ChatGPT 4.0 to run everything, right? To answer every single query. Then 70B. 70B, not as good as Llama as ChatGPT 4.0. So then we did some fine tuning with our own data against Llama 70B. That proved to be a little bit better, right? But the cost was still roughly the same. We look at the server cost and the API cost from ChatGPT 4.0. Then now we say, okay, do we need to use Llama 70B, even though it's fine-tuned for these specific questions? That's where the routing came into play. And we start seeing how we can move the queries to different models based on what it is that the question is. And that was a huge improvement, like probably about 60% improvement in the sense of cost and an inference on those questions that just needed a smaller model. So that's pretty much the approach.
What factor or factors made y'all decide to use machine learning for this application?
So the thing was trying to not replace, but augment the human element, right? And the things that you have to do to plan a trip for someone, right? It's a lot of logistics, right? A lot of communication back and forth and trying to figure out what's available, what's the rules and whatnot. And I remember.
And an LLM is good for that? Is that?
Orchestration is good for that, not just an LLM, right? LLM is just gonna take the thing and say, look, I was trained on this data, here's a response based on what I was trained on. But what you need to do is orchestrate, right? You need to see, okay, and then you're dealing with real-time data. You're dealing with availability changing at any given time. So you can't just say, okay, an LLM, ChatGPT 4 by itself, or 5 or 6 or 8 or 9 would never be able to just say, okay, I'm gonna go ahead and book these 5 rooms for you. Because maybe the agent at the desk at the hotel just booked it, right? And how are you gonna let that model get that data into the model quick enough for it to be able to answer that particular question? So.
What did you use for orchestration?
Huh?
What do you use for orchestration?
We're using LangChain.
Oh,
Yeah. And then also
what is orchestration again? What high level?
It's orchestration is you have a model that's able to take the query and then think about, okay, which direction should I go to answer this particular question? So for instance, let's say you ask a model 1 + 1, right? I mean, these models can answer that question now by themselves. Well, let's say it couldn't because it's probabilistic and it might tell you 1.0002 or something, right? Then you would that agent or that orchestration mechanism would then route to a tool, which would be a calculator, and it would then say, "Hey, I need the answer for 1 + 1." Maybe you want to do something like. You see this a lot when you're using like you're asking ChatGPT 4 to do something and it will show you. It will write the Python code, for instance, right? Or whatever language you're using to then do the thing you're asking it to do. So the model isn't doing it. The model's writing the code to do it. And then, so that's kind of, I would say like internal orchestration, but it's taking a step and that step is going to go to an external thing where it's calling an API or even calling a couple of APIs to then come back and then put it together and then bring it back.
Thank
you.
Sorry.
But you had a question at one point?
Yes, are there humans in the loop of any of this?
Always. So you can never replace humans. You know, I don't ever want to replace humans, right? You have to, making the beds, right? Like sometimes guests have problems where they need a babysitter, right? When you're picking guests up, you'll be surprised the look on people's face. They've been traveling from Chicago to St. Thomas and they get on the boat and the baby's crying and you're like, hey, would you like some rum punch? And they're like, oh my God. You know, AI cannot do that. It just can't. I look at it as using technology as much as possible to augment what we do so we can do what we do best more.
So is the output going directly to the person that's making the query, or does it go to a human agent that then forwards it?
So let me try to answer the question like this. We have one company we work with. They have 5 agents that work in the office, right? The office itself is a huge overhead because of where it is, right? Apparently like $50,000 a month just to run the office. And without going into the revenue of what they make or anything like that, it's a lot of money just to have this office space to do bookings, essentially, right? So what we're looking at is taking away all the administrative things that they just don't have to do, right? The bookkeeping, the reporting for the owners, right? So for instance, we want owners to go into their portal and be able to see how much money they spend for the last few months on light bulbs, paper towel, right? You would be surprised. You know, I have one manager that she spends hours on the phone speaking to owners about frivolous questions. And it goes back to, I don't want to send that query to a big model or a human. Like, ask the computer that question because she can then provide a better service, right? So what we're trying to do is take away as much as possible from the agents so that they can do more and make more, right? Because then now we're able to, that $50,000 overhead, we're able to disperse that now as rewards, incentives, and then make the overall platform even better. Make sense? I'm on a roll, let's go.
I'm curious about your tech stack. Like you keep dropping names, like. Give us an overview of what the overall architecture looks like. Give
All
a
right.
sense of the scale of the effort required, people.
Yeah. All right, so from the bottom up, we use AWS as our cloud provider. We use EC2, S3 for storage, for blob storage. And then EC2 specifically, but EC2 we're using, we're running Kubernetes on top of that. So we have that for horizontal scaling. Right now, what I talked about today, as far as the machine learning implementation, that's running in Kubernetes right now. But our beta right now here, just the listing and the different services that handles payments and pulling from the graph database, because that is what the graph is what this is coming from. That is running on Fly.io. It's a serverless. It's really easy to just deploy stuff to it. So we have that just for this, but that's going to move over to Kubernetes. In front of Kubernetes, we're using Rancher for monitoring the Kubernetes cluster itself. Nginx for ingress. Let me see. We were using Vercel for the front end. We switched to test it. Just running the front end on the same thing, Fly.io. So we put in a Docker, it's a Next.js web application. We Dockerize it, add it to Fly.io. That has been doing really good. The reason why we moved from Next.js is because Next.js, what we didn't realize, and this is why these cloud providers or people that come with these frameworks and then they get you into this into the loop, man, they're smart. So every time the documentation in Next.js tells you to use the image component. The image component is great because it does image optimization. Well, then we have all these images and they're always getting optimized, and Next.js starts sending you, not Next.js, Vercel starts sending you an email saying, hey, you just used up 75% of your compute. I was like, for what? I didn't do anything. They're like, yeah, you did. You optimized your images, but you told me to optimize the images. Well, whatever. So we're just basically taking the framework, putting in our own Docker, Fly.io, we don't have to pay for any additional or specialized compute, I should say. So now the next one will be to just put it in, run it in the Kubernetes cluster and have a couple instances running of our web application in the cluster. So AWS FlyIO, Kubernetes, Nginx,
React App on top of Next.js.
and
React App with Next.js on top of Docker container on all the Docker container deployed with Kubernetes. Yeah.
exactly.
All your APIs,
Huh?
you have your own APIs, I'm assuming. right?
Yeah, so most 90% of APIs right now are coming from FlyIO. They're running on that thing. One thing that we did do, which was the one engineer, he made a suggestion and I thought it was interesting, was normally you have this microservice architecture, right? And you have you deploy a binary for each individual service. What the decision was made was to roll everything up into a single binary, but it still has individual the individual modules within the code itself. So at any time, any instance can be any microservice. So if you want this instance to be the payment service and the authentication service, it will then run as that. And then you can use the autoscaler to then scale up. I want 3, 4, 5 of that instance. And if you say, okay, we're getting a lot of requests on people searching for something, we have the searching service, then you could just say, you know what, I want to dedicate this instance to just for search. And then you could scale it up and down as you need it. Okay. So that, and then we also use Redis. We use Redis as the backend store for pretty much everything. We're moving to Postgres. That was a dumb idea, but we did it because it was quick. We already had, wrappers around for Redis, but that was just a dumb idea. So we move into Postgres for most of that. We have Redis also, Redis streams for handling the eventing right now between those on FlyIO. But in the Kubernetes cluster, we have Kafka running. So we're gonna move off of Redis and then Redis and then go to Kafka for our event publishing.
Okay.
Problem.
Just one quick question. Why Kubernetes instead of Lime? Because you're scaling different services. That's understandable. And then everybody now actually make those
Yeah, is it Kubernetes instead of what?
limits.
Lumnus?
Yeah.
I don't think I'm familiar with that one.
It's actually, you don't have to use the infrastructure, and AWS manages the infrastructure for you.
Oh, so we use what's it called? EKS to manage the control plane.
Yeah, so you should manage something. Then does it serves on top of that where you manage even less. Still don't want to do all the.
Yeah, I want to make sure I get what that is. I don't know what that is, but I want to know what it is. I would say one direction that we did try to go initially was using Nomad. You familiar with Nomad?
No.
It's from HashiCorp. So it's another orchestration platform. This wasn't a big enough community around it. I think for me personally, I'm very comfortable and confident in Kubernetes. I feel like I'm not concerned about something terribly bad going wrong. Everything that we do is in Terraform. So we literally can spin up and destroy at a heartbeat, So, but I'm always, it'll be hard for me to see. I would like to see something that's better than Kubernetes. But I think the biggest reason, if there is a reason for why we went Kubernetes without going any other different implementation, would be because of the community that was behind of it, the size of the community.
We have time for one more question.
Now, what volume of data do you process every day?
Sorry, say that one more time.
Volume of data, terabyte, gigabytes.
Well, we don't have that much data right now, to be honest. The biggest corpus of data that we have right now is through one of our partners. They're essentially providing us all of their emails. So we scrub all the emails, all PII, and then we use that to fine tune. There's a lot of questions and answers over time that has been in those emails from actual real people. So, we're creating a data set with that. And I think, honestly, I would kind of make it, it's somewhere around like maybe 30 or 50 gigs of data, And to be honest, maybe in that data, there's some images in there. So it's probably gonna go down to like maybe 15. So it's not just that much data right now, but I do see once we do hit the milestones that we have on target for, it's gonna be a lot of data because we're looking at everything, right? We're looking at everything, especially now, to figure out what is gonna be most important in us figuring out how to create those curations. Some things we're gonna just drop, like no one cares about the fact that the car is blue. So we don't need to, that's a crazy example. We don't just store that data point, right? But if the car is 4-wheel drive, that's important. So we need to store that. But right now we're storing the color blue and 4-wheel drive, if that makes sense. Yeah.
Well, good stuff. Another round. Yeah.